Please introduce yourself.
Hi everyone, my name is Natalia Kosmina and I'm a research scientist at Massachusetts Institute of Technology Media Lab. And for the past 15 years, I have been working on brain-computer interfaces.
What are we talking about today?
Today we're going to talk about our latest use case application, which we call Ddog. Ddog features a spot robot from Boston Dynamics, as well as our custom-made proprietary brain-computer interface in the form factor of a pair of glasses, which is called AttentivU.
Demo time.
Yeah, we have something new to show, and the project is called Ddog. It features the spot robot from Boston Dynamics and AttentivU glasses. So again, our wearable wireless form factor that does pick up brain activity and eye movements of the user, so just here. And we call it internally think it to get it. So it's literally, for those who have not seen what spot looks like, you can see right now behind me, it's a robot that looks like and reminds you a dog. So it's literally a dog-like robot, and you are able to control it and to send it within the space to bring you objects. For example, it can bring you a chair, can bring you some shopping stuff, can move from one place to another, can also open the doors, etc., etc.
Tell us more about different form factors for brain sensing.
Yes, so definitely you can see right now on the screen behind me how it all started. On some of the photos there, I look like an octopus, let's be super honest, and how it is going. So definitely there is a lot of progress that brain-computer interfaces, or BCIs, have made since then. So we have a lot of minimalistic or miniaturized form factors. However, let's be super honest, you're not gonna run around with even a headband. Maybe if you're a sportsman, possibly, maybe in the office space, possibly, but you're not gonna walk around. And the challenge with brain sensing is that you need to collect data, a lot of data. And this data is very expensive to acquire and it's not available. Meaning that unlike computer vision, where data is all over the place and easily accessible, brain data is not easily accessible and is not available. So if we want to effectively bring brain-computer interfaces somewhere from 0 to 1, as we like to say, we need the data. Like, there is no other secret. It's not about killer app or whatever you hear about, maybe XR or other hardware systems. This is right now about the data. Data will be the key, and data is the key right now for succeeding in these applications. So octopus applications, as I call them, are great for the lab, in-lab research. Headband, nice because it allows for a lot of students, a lot of DUIs, a lot of labs that might not have easy access or enough funding to afford their heavy-duty lab setups. However, the project, the hardware, the form factor I'm excited about and my users are excited about are wearable portable form factor. I'm specifically talking about the ones that can be worn by you each single day, multiple hours a day, in any condition, meaning that you're driving a car, you're in the office, you're now recording a video, whatever the use case is, this form factor can support you, be with you, and if needed, you can discard it very easily.
Brain sensing glasses.
Talking about the glasses form factor. So this is the form factor here, and that's what we call AttentivU form factor. We are already wearing a lot of things on our head. Think about the headphones, think about the glasses, sunglasses, face masks, how many hats, etc. So we already have an easy access to this data. We just need to now enable this data collection within these form factors.
What excites you about Ddog project?
It's a POC, so it's a proof of concept. So it's exciting, obviously, within the space of being able to interact with such a big industrial scale robot using the brain activity. To the best of our knowledge, this is the first time that this type of application was developed with the spot robot. So Ddog, in brain controlled spot, is the first version for consumer grade and use case. This is very exciting. But also what is more important is to raise awareness about the need of these types of robots in the consumer space. Spot is an industrial type robot, and we're not going to sugarcoat it. It is an industrial type robot. However, and we're going to talk about this, I know, a bit later down the line, these types of robots do need to be considered, maybe not exactly this form factor, but for the consumer space, meaning home use, hospital use.
Why did you build Ddog?
The one is called Brain Switch, and this is the project that is a communication support tool for people who have very advanced stages of ALS. I have been doing this project for the past 10 years, I believe. So I started when I was still doing my PhD, and I have been continuing working on this project. So we have actually a very strong, not only literature overview base, but we've worked with multiple nonprofits. We worked with multiple consultants. We have covered, as of now, 2 continents, 3 countries, a lot of collaborations, but more importantly, a lot of patients and caregivers who are already using our AttentivU system. And with them in mind, the step was the following, the thinking was the following. So for those actually who were not aware maybe of ALS, you are very lucky. It's a very unfortunate disease. It's what we call neurodegenerative disease. So there is unfortunately no cure, and our system obviously does not provide any cure. However, in the beginning of the disease, there is a lot of assistive, what we call assistive devices, assistive support tech available, like eye tracking, voice recognition. However, in the very advanced stages, there is no more eye movement available, no more voice available, no more muscle control available. The only activity that is left is brain activity. At this stage, 93% of Americans refuse being intubated, so going on ventilator. They refuse to be having any type of support. So they give up. And this is unfortunate and understandable. However, they do have a way of communicating, which is brain activity. So initial version of Brain Switch that is used right now, so we are using it right now with our patients, is allowing you offer easy, basic communication. So it's really yes and no type of communication between the caregiver and the patient, between the user. And the Ddog is actually a next step. So it enters this loop, this infrastructure, this ecosystem that we have already built with our patients, with our front end and back end and devices, and we're going to talk about this later. So this is done more in mind of future development for smart home control enhancement and also robotic support. We have already been doing smart home control. So for these patients, you can check another paper that is available. So in this case, it's a smart home. What it says, it's a series of different interconnected IoT devices. So TV would be turned on if you think about the TV. A microwave can be turned on if you think about a microwave, etc. So this we have already done. So Ddog is a natural next step in this iteration. Having an assistant for you that is capable of understanding your need, if you are only able to express this need using your brain activity, able to turn you, able to turn on music for you, and provide any other support or alert another person in case you need additional and critical assistance.
Tell us a bit more about the tech stack of Ddog project.
So first of all, we're going to be sharing a paper, so it's not just a video, but it's going to be also a paper. So for those among you who are interested or willing to replicate the system, you will be able to actually check the more technical parts or technical details, and that's what we call tech stack, described in the paper. So stay tuned for this one. But in a nutshell, so it is actually designed, as I already mentioned, it is designed with thinking about the end user, while the system will be provided to the users that can support them. And by system, I mean really robotic part. However, We already have, as I did mention, a BCI, so brain computer interface part, which does have heavy AI behind it. So it's a deep learning, which would analyze the data, the brain data of the patient, and will train to recognize the specific patient's brain patterns. So effectively, when you think yes or you think no, this can be used, and the system can give what we call inference, basically a response. Is this a yes or is this a no? And then there's obviously a whole separate pipeline for the robot itself. So it's a computer vision, as you might imagine, because the robot does have cameras. The robot needs to know where it is in the space and how to navigate the space. So this needs to be in this, what we call mapping. This needs to be happening, and this is the robot side of things. We got help with the robotic part by the company called Reactive Lines, so shout out to them. So they were a huge support there. Called arm, and this will basically is the key component for the caretakers. Actually, it's the one that a specific can carry, so recognize an object, can pick it up. It's non-trivial task, just so you know, for those who are not maybe that familiar with robotics. It's non-trivial task to pick up the object. You can see the end of the video where we're picking up a toy or trying to bring a little chair on the wheels. So picking it up, putting it in a basket, or giving it directly to the user, recognizing where the user is and where they're picking up. So they can be provided with this support of effectively getting something from the dog, so being delivered to.
Could you share more about the infrastructure of Ddog project?
We actually had some of the choices that we made were predefined already by our existing ecosystem and infrastructure. So what I mean by that is that, as I mentioned already, the hardware component, so the brain-computer interface, this was already proven. We have another form factor, but this is already a proven interface and form factor for our users, so we kept it. What you all have is a mobile phone or mobile device or a tablet. So we, for example, did have a mobile device, specifically an iPhone, that we already providing to our users as part of their trial with BrainSwitch, because not everyone has a device, and to unify all of our users, we provided them with the same devices. So they already having an iPhone and they are running the BrainSwitch on the iPhone. So in this case, we kept this part of the infrastructure of the tech stack intact, and we added the second part with the help the company mentioned, Reactive Lines, who supported us with the manipulation part and CV, so computer vision part, and mapping for the robot. And it also runs, actually, just to make sense simply, on the second iPhone. And in the very end, we have a fully portable, mobile, wireless system that runs on 2 iPhones, 1 pair of glasses, doesn't require any backpacks, any heavy machinery, and is fully autonomous.
What are other robots that could be used at Ddog project? Why did you select Spot?
However, as I did mention already, though defense use cases and military use cases, policing use cases are the most, I would say, publicized use cases. We have already seen how they're not, first of all, most successful ones. I'm just gonna talk about those. I'm gonna bring you a couple of highlights. But also, as I mentioned, I think there is just not enough use cases for users who actually can truly benefit from those systems. We took sport and we got sport just because there's really nothing else out there that is of similar type. There are definitely manipulation arms, absolutely, but they are usually static. So you would have a base of the arm and it would just move like this. Hopefully you can see me moving right now. So that's one type. There are humanoid-like robots. Are a lot of things to say. Well, in a nutshell, they're not yet ready, definitely to be deployed, and their use case are more heavy carry, and they might be a bit of their overkill actually for this specific use case we are targeting. And then there is, because they do need much more maintenance, they're much heavier and they're usually much bigger. There are exoskeletons, extremely powerful tool, absolutely in it. You might know in France, where I'm from, there is effectively a lab a tech that does excellent research in practical use case for the exoskeletons. However, they do invasive only, and to the best of my knowledge, they only had 5 patients actually implanted with the system over the past 8 years, which effectively takes a lot of research and a lot of funding to make it right. The system runs, but those are extremely expensive, over one, so we are talking 7 figures there and more. So all of those basically bring us again to this point that sport being industrial, we didn't find any better. And please do not start me on like Astro from Amazon or others. They just don't do the use case we need to do, so they're effectively supporting the user. They also only do like voice recognition. So, and we need really the ones that can carry and bring objects.
Could you comment on defense and military use cases?
If we are gonna roll back to the military and policing and defense use cases, there are quite a few videos. Just one, I think, of the recent ones, effectively maybe a week ago or so, did actually even feature the sport robot control using HoloLens and some EEG electrodes. I believe that is from Australian Defense Department. You can see it right now behind me. And there is some challenges with those. So first of all, actually 2 main challenges. You can see, well, HoloLens being as in headwear, pretty heavy, pretty expensive piece of machinery that only lasts right now 2 hours of the battery life. So that is being a bit tricky for the end consumer to actually navigate, use, and obviously this is just not usable in our use case. And the second one, well, you can see on the video, they have electrodes looking like behind the ear, so very similar location to ours, effectively to AttentivU, which also is behind the ear. However, those, as you can see, are sticky and seems like wired electrodes.
Civilian use case.
And nothing bad with those. However, again, thinking about end use case, civilian use case, the mother who just came 7-8 p.m. from full 12-hour shift, no one is gonna stick those. Like, no one. And I can tell you from my 10 years experience with this population, you need to go with wireless, you need to go with the ones that do provide contact, but that you can just put on easily as one piece, make it comfortable.
Ethical considerations.
And the final point, of course, is ethical considerations. Military and defense being obviously very important use cases to support the people who might not be able and should not go and put themselves in danger. Like we already saw sport to be used in like nuclear facilities and others, so where there is a danger, and obviously a robot can take all the danger and also be used to check for the environment, spaces, etc. However, a lot of use cases we have seen as well. Possibly, like I believe New York several months ago, the police tried to use sport for policing, for monitoring, and that did not go very well. So I would just be cautious about the use cases and possibly, getting more conversation going before this early release of these systems in the wild. What we call in the wild, scientifically speaking, is out there in production, so with the population. Like what we have done, we have a video, we have a paper, we will be continuing the research. However, the system is not ready to be deployed yet, not just because of the grade of the robot being industrial, but there is more conversation that needs to happen legislation-wise as well. Are we effectively ready? I mean, if there is conversation starting, and we can see how it goes with AI. For the brain sensing, there's even less legislation. There's like even less discussion. And this data is much more critical. This is the most intimate data your body can produce. These are your thoughts in the very end. And we are not talking thoughts per se, this is not mind reading, but just being ready of having this critical conversation going and understanding that some systems might need to stay in the lab and have conversation going, but they just should not be released yet.
What is the future of Ddog?
We are going to be releasing the paper together with the video. So for those who are very interested, you can learn more, so the tech stack, and see if actually this is of the interest to you to possibly collaborate or even possibly try to replicate some of the parts with your spot or with other robot of the similar type. However, as I did mention, there are two directions. One is manipulation, so the arm part. That is pretty critical, and this is actually critical in our use case application. It's very important this arm is mobile and can effectively bring things. So we definitely want to explore this arm manipulation further and hopefully explore it together with our end users. As of now, you have seen the video that recording is done on myself in the very controlled conditions of a big room as a lab.
Any crazy use case you would want to implement?
Protective version. So the one that would pick up your fear or your stress level. For example, as you can see in the video, we are recording, and as full disclosures, that is the lab, and you can possibly see down there it's pretty dark. It was night, and you know, what if someone would, you know, come over and possibly be aggressive or unpleasant, and I would not feel comfortable. The dog could have sensed that and either called for help.
Ddog and STEM.
And then the second direction I do want to undertake, heavily being inspired actually by what's happening here in Massachusetts. Let's be very honest, there is a whole series of workshops happening for children in the schools in Boston and greater Boston area about engaging with sport as a programming robot and introduction to STEM, and that seems to be doing very well.
Contact information.
Right now behind me the image with all the coordinates, the website, the email, so you can email me at nkosmyna@mit.edu with all your questions. You can go and check either the Media Lab website or my website, brainy.io, to read more about Ddog, but also about other projects that we mentioned, like Thinking Cap, Brain Switch, AttentivU, or actually there is much more on the website. Don't hesitate to get in touch.
Thank you for your time.